This is Alberta's Peace River country, big, bountiful, scenic. 300 miles north of Edmonton. The town is a modern community. The people retain the pioneer spirit and community interest that developed this region. The date was July 31st, 1968, and they came out in hundreds. Townspeople, local officials, engineers, and builders. Alberta's Minister of Highways and Transportation, the Honourable Gordon Taylor, was there to officially open the bridge. It was a time for tribute and praise, satisfaction of achievement. It was a time for celebration. The Peace River had been crossed once more. The highway that comes into the town is designed to accommodate the ever-increasing traffic flow and serves as the vital as a timber traffic deck on a railroad bridge used for highway vehicles when no train was crossing. The traffic was all the old structure could accommodate. Travelers in the area can easily recall the waiting at one end or the other as a long line of oncoming traffic crept across. The increased mining activity in the north meant more trains and longer delays for more vehicles. It was clear to the Highways Department that the old bridge had been passed by due to the great development of the area. It was time for a new structure built to keep pace with the region. The designers chose a steel, tied-arch bridge supported on 4 piers located about 300 feet downstream from the railroad bridge. The theory behind a tied-arch bridge, which is a closely computed scientific concept, is that a base girder placed between 2 piers can be given support by an overhead arch. The arch, in turn, is given structural support from the girder when securely tied together at each end. Soil borings showed a 45-foot thick layer of shale 30 to 40 feet below the water level, overlaid by a layer of gravel and boulders. The bridge branch engineers were given the job to plan and design the crossing and the additional challenge of constructing the substructure. This procedure became necessary when 2 calls for tender were unsuccessful. Work commenced in the fall of 1965. A decision was made by the engineers to construct the 2 easterly river piers. Access was gained by means of a berm, which is a road built into the river from which the work is done. The method chosen required that rocks and gravel be removed first by using a combination of blasting and digging with a clamshell bucket. This work was to be done under 30 feet of water. To place the footing in the shale 50 feet below the water, a steel cofferdam was chosen. Approximately the size of a 6-story building, the steel frame was assembled above the surface, then lowered onto the riverbed, lined with steel sheet piling driven into the river bottom, sealed, and pumped dry. This allowed men to work in dry conditions on the river bed. The large cofferdam frame was moved by machine to the site of the first pier. 4 lowering towers were built into the frame. Steel sheet piling was welded to the frame to serve as a guide for the rest of the sheet piling once the structure was underwater. Slowly, the large structure was lowered into the icy water of the Peace River. The steel sections were set up and driven by diesel hammer, 1/8 of an inch per blow, to a depth of 7 feet into the hard shale. Up to 10 pumps capable of moving 100,000 gallons of water a minute were started as the dewatering of the cofferdam got underway. The river was not going to be kept out easily, however, and the water level within the square dam did not lower appreciably. Working in temperatures of 30 degrees below zero, the work of dewatering the dam went on. A diver checking the bottom seal of the structure found no leaks. The leaks then had to be in the joints of the piling. The leakage was stopped by cinders, coal cinders, located with some difficulty. Placed along the outside of the cofferdam, the cinders gathered and plugged the leaks. Quickly, the water level within the cofferdam started to lower, and within a few hours, the river bottom lay bare. The icy weather that had slowed the work now joined in the effort to freeze any further leakage into the dam. Pumping was unnecessary. On the river bottom, further excavation was begun. It would be necessary to dig 14 feet below the river bottom to final footing elevation. The tricky task of lowering the excavation equipment to the bottom of the cofferdam was accomplished without incident. Every workman knew that the steel walls of the dam were under tremendous pressure from the river water on the outside. They also knew that damage to any supporting beam within the dam, perhaps while the machinery was being lowered, could weaken the entire structure. The auger drills bit into the shale, making holes for the placing of 40 concrete piles, each 30 inches in diameter. Moving from one drilling site to another meant the partial disassembly of the drilling rig. Each move was accomplished in 2 hours. The 3 cubic yards of material excavated from each hole was shoveled into skip containers and hoisted to the surface by a crane. The hazard of hitting the supporting beams while raising or lowering material remained. During the excavation period, the weather remained at 40 to 50 degrees below zero. At these temperatures, thick steel can shatter like glass under impact. As each hole was drilled, reinforcing steel was placed and the concrete poured. The pier footing containing 400 cubic yards of concrete was poured neat against the excavation. On top of it, a 550 cubic yard pedestal was formed and poured. During this part of the operation, insulating arrangements had to be used to offset the bitterly cold weather which continued to plummet to as low as 50 degrees below zero. Concrete pour of 200 to 300 yards took approximately 12 hours, with the insulation enabling the concrete to be kept at a temperature of 60 to 70 degrees. With the initial work on the pier completed, plans were put into operation for the removal of the sheet piling and cofferdam. Flooded once more with the icy water of the Peace River, the preliminary work of removal was begun. The large hammer was again used to drive the piling even further into the river bottom. This action loosened the steel piling, and it was removed with an air extractor. The cofferdam bracing was then raised and salvaged for further use, leaving the finished pier. At this point, the bridge branch staff decided to take a calculated risk at Pier 3. If the water level could be kept down with constant pumping, there would be no need to construct a cofferdam as had been done on the other pier. The result would be a large saving in time and money. The decision was made to use a glory hole. Though some problems had to be solved, the glory hole was a success. The work went faster than with the cofferdam, due in great part to the easy access of the required machinery. Warmer weather heralded the start of spring, but it meant trouble in the river. The water was rising, and the work took on a new urgency. It was clear that further work on the river would be impossible until the following winter freeze-up. The workmen welcomed the change of working in the hot summer weather for which the Peace River country is noted as compared to the bitter cold of winter. To the people of the Peace River and the riverbank superintendents that are on duty at every construction project, it looked as if a bridge was taking shape. Two piers were now clearly visible above the surface of the water, and the piers and abutments were completed on the banks of the river. The calculated risk of the glory hole had proved to be a good decision, and the favorable cost encouraged the bridge branch to carry on the project as a departmental effort. The decision not to call for further tenders on the bridge meant additional planning for the coming winter. Material was moved to the site, and preparation for further construction was completed when the river water level started to drop again in late August. Construction resumed, and access was achieved by the use of berms and bailey bridges out into the river. These structures, well known to military veterans as a means for transporting material on a temporary road, reached out to where the pier construction would continue. On each side of a pier under construction, work bridges were placed to allow the movement of steel and construction material. Bailey bridging was the mainstay of these temporary structures. Special methods had been devised for the problems peculiar to the project, and the imagination of the bridge branch engineers resulted in a substantial saving. For example, a blasting device had been built, which was the solution to the problem of excavating underwater. At the end of a large shaft was welded an open pipe. The pipe was fitted with a bottom cover and a further protective plate. The charge was dropped into the pipe and lowered to the river bottom. After having been hammered into the hard gravel and shale below the water level, the charge was exploded. The clamshell bucket was immediately lowered to dredge up the loosened material, and little by little, the river gave up its soil. Further use of the cofferdams on the other piers was required. A slight change in procedure saw the cofferdam frames constructed in the final location on floats instead of being pre-assembled and rolled out. The towers were again used to lower the frame, and the cofferdams were completed. Nature was kinder to the workmen, and the job was ahead of schedule. More tons of concrete and steel were being placed. New ideas and methods were constantly being introduced as the construction advanced. The pulling of sheet piling in the cofferdam was accelerated by the use of a new machine not previously used on the prairies. The vibrating driver extractor literally shook the steel piling loose from the hard clay bottom. The removal of the cofferdam from the last river pier was done at a faster rate, as the worn cofferdam bracing had seen its last service. During the winter of 1966, steel began arriving on the site, and in January 1967, the first steel erection was begun. Under each span, falsework bents were used to support the stiffening girder sections. Each section was 90 feet in length and weighed more than 28 tons. When a section of stiffening girder was in place, a temporary decking was laid to provide access for the cranes which would build ahead. The hangars, consisting of 10-inch diameter steel tubes, were connected with the stiffening girder as compression supports for the arch during erection. The spans crept across the river. The first span was completed by March, and the approaching spring breakup became a factor in the planning. Although it was getting late, the superstructure contractor decided to go ahead with another span, while department crews speeded the removal of materials from the river. Again, the risk paid off when the span was completed by the end of April, with a resultant further advance in the schedule. The permanent decking could now be placed on the two finished spans. Using a monorail buggy system, concrete was poured into the steel framing, making the base for the road which would span the Peace River. On the old railroad bridge, the people of Peace River and the tourists who crowd the area during the summer watched the construction and waited for the day it would be complete. The project was going well. More than 3,000 tons of concrete was poured to form the decking. The additions that make a finished bridge were starting to take shape. The summer and fall of 1967 saw the return of work on the spans. Since no access berms could be used in this deep portion of the river, cranes drove the piling for the falsework from a barge. Using a diesel hammer, the piles were driven into the river bottom. Working directly from the barge, the falsework towers were erected and the construction on the other steel arch spans was begun. Following the same pattern as had been established before, the steel arched to join the piers across the water. The last steel was being placed. The time had almost come for the finishing touches. The falsework, which had served to erect the steel spans and girders, could now be removed. The piles were pulled and the water swept over, leaving little sign that falsework had ever existed. Decking to complete. More tons of concrete rolled out on the monorail buggy. The hot summer weather returned. A sense of excitement was pervading the town of Peace River. The spans were across. The painters started the big job of spraying 2,000 gallons of light green paint to the steel spans. Every exposed steel surface would be covered with several coats of attractive enamel. The Highways Department continued its practice of having colorful bridges. It was done, from the drawing board to reality. Countless computerized calculations, hundreds of memos, scores of invoices, all aimed at one end result: to bridge the Peace River. This is the story of how the 20th century pioneers crossed the mighty Peace. The imagination and strength which characterized the first pioneers who crossed the water were in no less abundant supply now than then. The Department of Highways Bridge Branch, in undertaking to construct this bridge using department personnel, established a standard of efficiency that would be the envy of many builders. But a bridge does not simply happen. It is the effort of hundreds, some of whom never get near the site. It is built on the effort of administrators who make sure everything is where it should be when needed. It is the effort of engineers who had the opportunity to see one of their dreams come true. And finally, it is the effort of the workers who worked under severe conditions to make the project a success. The men who worked on it will remember with a sense of pride that they bridged the Peace.